folks, welcome, 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 and welcome out there. Afternoon, evening, whatever time, anytime, any place, you're watching us. We thank you for tuning in. I'm Ernie Roberts. I am your host for this session of Mathline. Now, it's summer school. It's specialized segments, so you don't need to call in. You can always still check us out on Facebook and watch us on YouTube and send us emails and things like that. We'll be glad to address those things during the summer course. But remember today, you need some paper, get some pencil, and I would definitely go for a calculator close by. We're going to be looking at, well, some of those things that wreak fear in the hearts of men and women, things called story problems and word problems. Let's see where we're going. What kind are we going to focus on today? Oh, we have a cure, in fact, for your motion problem worries. Now, that's not motion sickness, all right, but we are going to talk about motion because we're going to be moving, whether we may be working with planes, we may be with trains, automobiles. Oh my goodness, cyclers, runners, you got it. There's so many ways we have motion going on. And the formula, RT. What does RT mean? Rate times time, and you know what that gives us? It gives us distance. So let's take a look at some simple moments, and then let's apply them to something maybe a little more complicated, all right? So let's look at the first problem we got here. It says use the formula D equals RT to find the distance if a cycler travels at 11 miles per hour for 4 hours. Straightforward. Everybody says, oh, Ernie, that's easy. I can handle that. Let's go through it, because if we can handle the little things, we can put them into bigger context, hopefully, and handle them just as well. So starting right off here, I've got this little D equals RT. Now remember, R and T jammed together, meaning we multiply those. So it's rate times the time, or multiplied by the time. And D stands for distance. What are we looking for? We always want to figure out what is it we're looking for. So keep in mind, D is distance, ta-da. Rate, how fast we go. And time, how long is it going to take us to get there, all right? So we are moving at 11 miles per hour. So there's your R. And by the way, I know some of you kind of want to know now, how do we go from miles per hour and hours to miles? And some of you are going, we really don't. But I want to go a quick show here, because we're not going to get into this very much along the way. But this is what we're saying. We're saying 11 miles per hour times 4 hours. And look what happens. Your H's cancel out. It's like a little fraction there. We can put that under there. So we call this a little dimensional analysis, fancy word for basically watch your units cancel out if one's in the numerator and one's in the denominator, all right? And what are we going to be left with? 11 times 4, we got it, 44. And you know what? That's going to give us miles in the end. So there's your context. Back to the problem. Very straightforward. It's multiplication. By the way, remember, all this good old algebra, all these formulas basically entail, 4 operations: addition, subtraction, multiplication, and division. Even when we do exponents, we're repeating multiplication, right? So hang in there with us, because our word problems are going to basically instill all those kind of ideas with us. We're going to be doing some adding, subtracting, multiplying, dividing today. And just got to be sure we do it in the right time, in the right place. Everybody good? All right, let's see our next problem, what we've got going for you here. It says, use the formula, where we are, back at that formula again, to find the rate if 420 miles are covered in 6 hours. This more sounds like a car type problem, okay, or a truck driving on the interstate, of course, certainly not through the heart of downtown, or would you have 420 miles in a downtown. This is a long range driving thing. Now, when we look for the rate, we're looking for the average rate, all right, folks? We're not looking for where it starts, where it finishes, or some particular point, because it's going to vary. It's going to vary. So we're looking for the average rate over this whole trip. And let's see what we've got. We've got R times T again, equaling that lovely D. We got D given to us, don't we? There it is, 420. Time, very good, 6. Rate, that's what we're looking for. So put the things in the formula, and we have 420 for the distance. Everybody get on that? Cha-ching, yeah, we got it. And 6 for the time. Let's just go ahead and put 6 in front and put R next to it. It means we're multiplying, all right? 6 times something gives us 420. Now remember, when we have a little multiplication, simple equation, and this one really is, we've got this situation here, that means we need to divide to figure out how the rate is when we have to multiply it by 6, you see? So to undo this, we're going to divide both sides by 6. And the nice thing is, 6 goes away, so we're left with R, our rate. Whatever we have here, that's our rate. It's nice it came out even, because we can say 6 goes into 42, goes to 7, Bring your 0 along. And by the way, what are we going here? We're going miles per hour, okay? Because remember, that's miles over hours. How about that, miles per hour? So that's another way to think about how do we use these units if we needed to work through them. We're going to avoid them because they're going to get rather complicated along the way, but I want you to understand this is what the process is. Take a rate in miles or whatever unit per hour times the hours, you're going to get that unit of distance, all right? So easy it is. All right, let's have some easy fun today. We're going to jack it up on you, right? You know that. You knew it's going to happen. So let's see where we're going. How about it? Southbound, northbound. Trains going 30 miles per hour one direction and a northbound train going 40 miles both leave the station. Oh, how do I know they're different directions? Because one is northbound and one is southbound, right? So what we're going to do, we're going to bring a little help here, a little visual aid. And I know you think, well, it's north and south, we're going up and down, right? Well, we're gonna stretch it long ways here, all right? Just because I don't have enough room to go up and down on this page. So let's go in this manner. We'll say this one is north, this is south. The idea is they are going in opposite directions. I know someone is saying, boy, you are geographically challenged, aren't you, Ernie? If you're just now tuning in. No, we're gonna let this be our guide. We're gonna say this is the north going this way, this one's going south. Now, who's going faster? Well, let's read the storyline. What are we going here? We got one going 30 miles per hour. There's a rate. Oh, but here's another rate. Two rates, so maybe we ought to call it rate 1, rate 2. All right, that's important. They're two different numbers. We'll see what happens with those in just a second. What's happening is they're both leaving at the same time. All right, so there's some point here. Looks like we're going to be somewhere along the way here. And going this way, we have a southbound train going at what? 30 miles per hour. Do we know how long? We do not, do we? So we're looking for T. We do have something about distance here. Now, that's kind of an important moment here. So let's see what's happening. This distance is what's going to be covered by the southbound train. So what do we got? Rate is 30. Remember, RT. We're going back to RT. What's our rate? Our rate is 30. Time, we don't know. Oh, wow, about that. Let's go to the left. Go to the north. Northbound's going a little faster. So its rate is 40. And again, we said same time, because eventually there's going to be one spot where we're going to be 245 miles apart. We want to figure out where does it happen. So here's your rate and your time. Notice this one travels a little bit more. Oh, no, it doesn't. It travels what? A little bit less. Now, why is that? Why is it 30T and 40T? What's the deal here? Well, guess what? You're going slower. So you're not going to go as much. You're not going to go as far. Your distance is going to be shorter, right? You're going back this way. You're going faster at 40. So you're going to cover more distance. But eventually, what's going to happen with these two distances? And I'm going to call it D1 and D2. First distance, second distance. And we're going to add those together to get how far apart are we? How far apart? Everybody got it? Hey, it was given to us, wasn't it? There's the 245. So here we've got D1, which by the way is 40T. Here we got distance number 2, which is 30T. What are we going to do according to our little formula? We're going to add these together. So let's do just that. 40T plus 30T equals our 245. All of a sudden, we have now gotten all these words, and we got to think of them piece by piece. Don't try to look at that and get overwhelmed, okay? That's what a lot of my students and myself, when I was doing these things for the first time back in high school and such, I would look at these things, I'm going like, whoa, they're crazy. Just take them piece by piece. Draw the picture. Make a table. A table is a great thing with rate, time, distance. I'll show you that just a little bit here. How about it if you put an RT and a D? And then you can come back and say, oh, all right, you've got SB, well, southbound. You've got northbound. And good old southbound's going 30. Northbound is going 40. The time is the same. And guess what? We don't know their distance, do we? They didn't give any numbers. They just know what it is together. So guess what? Distance is 30T and 40T. What are we going to do with these? We're going to add them together to get 245. So there's two ways to look at it. Let's call this horizontal. This is more like a vertical, all right? So these are still going to add up to give you 245 when you put a little plus between them. How's that? So again, how you set them up is it's little bits and pieces, all right? You've got two things. You know how to do those. You know how to do the southbound train. You know how to do the northbound train. Now you've got to figure out how do they connect. They're 245 miles apart. That's the distance between them. So let's get through the end now, since we've gotten all the reasoning of why and how this is easy, okay? So we're going to add 40 and 30. I'm giving you 70t here, equaling to 245. Now, what does this really say? This means our combined rates, because one's going this way, one's going that way, so we're adding them together. It's going to give us 70t, and now we're going to see, by the great divide, right? We're going to divide 245 by 70 and see how it works. On the calculator, by all means. Time looks like it's going to be 3.5 or 3.5 hours, 3.5, but some of you like to think about that as in hours and minutes, so that would be 3 hours and 30 minutes, all right? So how long, however you want to look at it, but that is in hours, remember, 3.5 hours basically, so you can change that to minutes if you wish. Question is, will they add up to 245? I think they will. If you go back, let's hit the calculator and see what we get. We're going to take 30, and we're going to multiply it times 3.5. And that's going to be our first little guy. Here he is, 105 miles. We're going to take the 40, and we're going to multiply it by 3.5. Because the whole idea, my friends, to check on this thing is, will they add up to 245? Well, it's pretty obvious they do. You can add those two in your head mentally, and you get what? 245. So it does check out. We get that 245 back. 3.5 is what happens. And again, it's interpreting. Hey, they're going opposite directions. Looks like we're going to add distances together, all right? Because they're getting further apart. Absolutely. Everybody good? All right, let's try another problem. All right, everybody good? Everybody's good. I'm always glad when everybody's good. Let's take a look at the next one here about Corey and his sister Cora. They leave town at the same time. Well, okay, do a lot of that, don't we? Oh, a little different twist. A different twist. Everybody, I like twist. Don't y'all like twist? Twist it up here. One is averaging 70 miles per hour. The other is averaging 66 miles per hour. Well, that's not so twisted. Oh, I left out the twist. They're doing what? Heading west. Anybody heading east? Absolutely not. They're going the same direction. So let's see if we can draw a little diagram of this, and then we'll play a table on it also. See if that'll help us some. All right, got my little track of road here. And this time we're going west. So we're going to start here. They go both the same way, right? They're going heading west, absolutely. So how do we deal with this? Well, we let one of them go pretty far. But you know what? Since they don't really get to travel right on top of each other, we're going to give them a different little lane here, all right? And let's see. We've got Corey. We don't really know which one is going the faster, do we? So I'm going to use this the respective manner. We're going to say Corey's going a little faster, okay? So Corey's this one, and what's going to happen on this one? Cora is down here. Now keep in mind, we're all about rate and time, giving us distance. So what are we trying to figure out? How far apart will they be in 4 hours? Now, remember, Corey's going faster. Cora's a little bit slower. And they're both going to go 4 hours. Does that make sense to everybody? They aren't going to stay the same place, are they? One's going to go a lot further. Who's going to go further? Corey's going to make, well, looks like he's going to make 4 miles more per hour. And I already just gave away, didn't I? But let's see how this goes. So we got Corey up here. We'll say he makes it all the way to here. Cora doesn't quite get there. She ends up here. So how do we write this? Keep in mind, this will be a rate. This will be a rate. Put 2 of them there. The time is 4 no matter how we do it, all right? So Corey up here is going 70 miles per hour for a certain amount of time. And we're going to put that number in just a second. Cora is down here going 66 miles per hour times that rate of time. And she doesn't quite get there, okay? She's now left behind a little bit. So after 4 hours, we're going to put a 4 in here. And here we go. I'm going to say this. We're going to say 70 times 4. We're going to say 66 times 4. But this time, what's going on? We're not adding distances together, are we, my friends? What are we going to do? We are going to subtract. Now, by the way, these are times. These are not decimals, so anyone should be tuning in right now. That's going to be the distance we have apart. So how about it? 70 times 4. We got 280 on that. Know your times tables a little bit. 66 times 4. Yikes, I'm not so sure about that. Let's check it out, see what we get. And then I'm sure someone's out there throwing things at the screen saying, Ernie, I've got a different way to do it. And I'm going to say, we're going to talk about that, all right? And I get 16, and that is miles. Okay, 16 miles. Now, what's another option we could do? We could have gone back up here and said 70 minus 66, put it in a parenthesis, and then multiply it by 4. You see, it's like doing a little distributive property in reverse. We can pull out the 4, a GCF if you will, and it's really not the greatest common factor, but it's going to work for us here. Because we're going to get that 4 times the 4, and guess what? We get 16 miles also. So this option works. This option works. Happy traveling when you go in the different directions. And I hope maybe Corey will stop at a rest stop or a restaurant or somewhere, and they'll meet up and they can make the rest of the trip together. Anyway, there you have it. Corey and Cora, thank you for the nice little moments there. So we had Corey and Cora. How about it? Let's go to Daphne and Diggy. I don't know if they're sisters or just friends, but I like these two, Daphne and Diggy. In a bike race, Daphne gives Diggy a half-hour head start. That is so nice of her to do that for Diggy, all right? Because you know why? She knows Diggy goes a little slower, all right? Diggy cycles at 12 miles per hour. That's his rate. Daphne cycles at 14. So we got two rates going here. Now this is one of those, how long does Daphne ride before catching up? And I know the first thing that some of you all are starting to think out there, how long does it take? How long does it take? Well, don't we need to know the distance? Wow, maybe we do. Well, let's talk about it here. What's the rate of Daphne here? She is going to cycle at, what, 14 miles per hour? All right. And Diggy's going at 12 miles per hour. So let's talk about it. Daphne, Diggy. And we'll play the table game here. We got a rate, we got a time, we have a distance. All right, we're going to look at it from a table standpoint. If y'all like to draw the picture out, this one's a little more complex, so let's do it this way. Then you could probably say, oh, I could do a picture real quick now. So what's the deal? Daphne gives Diggy a half-hour head start. That means he gets what? He gets an extra 30 minutes. So Diggy, we're going to give you 1/2 hour. You get extra time. You're still cycling at 12. That's not going to change. Daphne, she's cycling at 14 miles per hour. She didn't need the extra half hour, but she's going to catch up with you because she's moving faster and faster along the way. So now here's the deal. 14 times t. Are we good? That's the distance. That was easy. Daphne's pretty good, isn't it? Here we got Diggy, and Diggy's not so bad. Remember I said we might have to add or subtract some things? There we go. Now, let me bring back the fact I said something about a subtract there. If we had let Diggy have the time of t, we could let Daphne have, t minus 1/2, because she's going to be out there 1/2 hour. But anyway, so what we're going to try to figure out is Daphne's time. So that's another reason why I wanted to use t there. All right, so t is Daphne's time. All right. The important one on this one. So that's her time. Now, what are we going to do with these things? Everybody good on this? What's the question? How long does Daphne ride before catching up with Diggy? Catching up. That means what? They are going to cover The same distance. Everybody got that? You catch up. You started different times, but you've finally come to full circle here, or at least full line, I guess. But you're there. You've caught up. So, guess what? In this column out here, we don't add them. We don't subtract them. They're going to be the same. So here's the deal. We're going to say 14t is equal to 12 times t plus a 1/2. Oh my goodness, now that makes sense, does it not? Daphne's going a distance. Diggy's going the distance. The same distance. So let's distribute and find out where this goes. We distribute our 12 all the way through there. We got 12t plus 6. That's straightforward. 14t over here, playing the game with it. Now, if we'll drop out that lower part here, we'll finish this one off. We're going to lose 12t to both sides. All right, everybody good on that? Minus 12t. And here we have it. 2t. Say goodbye to your 12t. That was a minus, by the way, not a 72. For those who are just tuning in, I always say that a lot of times because sometimes people break in at strange times and we never know. So t is 3 hours. So Miss Daphne is going to be out on this bike race place for 3 hours. Probably then she'll keep moving on at the same pace. She'll win the race if it's still longer. Diggy's going to take 3.5 to get the same distance covered. All right. So what was our answer here? 3 hours, because that's what Daphne spent. That is for Daphne. And should it ask about Diggy, good old Diggy, he'd be 3.5. Everybody good? Everybody good on that? And they check out very nicely because let's see what the distance would be. If you take 14 times 3, it's going to give you 42 miles that they've traveled. If you do 12 times 3.5, I guarantee you, 42 miles also. All right? And there's your story on this one. Not so bad, is it? So once again, we've seen distances where we added them. We've seen distances where we subtracted. And now we saw distances where they stay the same. How do you know that? You read the context. Context of your problem tells you everything. Let's take one more quick look here and see what we've got here. We've got Angelo driving one direction at 50 miles per hour on a trip, and then he returns at a 70 mile per hour rate. The round trip lasted 6 hours total. What was the distance covered one way? All right, so let's go straight to the RTD because we're running on time here. RT and D in our situation. Remember the distance, by the way, it's going to be the same, right? Because it's a round trip, blah, blah, blah. That's the hard thing about this. So rate, let's see. We'll call it out and back. How's that? Out back. Good place. Let's see. Out, we went, let's say at 50. Coming back, we hit 70. Maybe there's less traffic or whatever. Remember, these are average rates. Time, I don't know. I got T. Oh. Guess what? Did the same distance. This one should be less. Now, how much less? Think, oh, or maybe it's, yeah, it will be less. The less time because we're doing the same thing, right? So let's go with, are you ready for this? 6 minus T. You say, how does that work? That's because let's say I had 6 hours total, and let's say I took 4 hours out, that would give me 2 hours coming back. You see? 6 minus T, not T minus 6. Very important. So now let's play it out here. Rate time. Okay, here we go. 50T. Over here, 70 times 6 minus T. Are we ready? Set those things equal to each other? I think we are. Let's do it. All right? See what's going to happen. I got 50T. Let me put it right down here. 50T equaling 70 times 6 minus, are you ready for this? Not 6, no. Times what? Yes, 6 minus T, and we're ready to work it out. Let's go ahead and distribute. I was getting a little ahead of myself. Sorry, guys. 420 minus 70T. Over here we got 50T. Everybody good? Now, how do we get rid of a minus 70T? Yeah, we haven't done one like this, have we? We're going to add that 70T to the other side. And that gives us 120T equaling to, 420. I think a calculator is in order here. Let's see what we get. 420 divided by 120. And we get another 3.5. Everybody said, boy, you like that, don't you? So 3.5 hours. But one way, how about it? We need to figure out what one way is. Let's go right here. 50 times 3.5. And you know, real quickly, let's take that 3.5, multiply it by 50. We're going to gun this right down to the wire. 175, that's how long that trip is. And you can check it back over here, and 70 times 2.5, it's going to also give you 175. There you have it, folks. How about it? That's your storyline today. I hope it was good for you. I enjoyed it. We'll see you next time. Hey folks, it's Ernie Roberts from Mathline, and you know what? I want you to remember that we're going to be around this summer. Now, we're not going to be able to do live call-ins, but we do have summer school. We have some skill review. We've got test prep shows. We've got all sorts of things coming your way. To watch us online, watch us on your PBS station. Take care of business this summer so you'll be sharp in the fall when you return to school.
Mathline, weeknights at 6 p.m. right here on East Tennessee PBS.
Welcome to Amanpour on PBS. I'm Christiane Amanpour in London, giving you the global view. I've covered the world for nearly 3 decades, and I'm dedicated to bringing you all the facts. Please join me for conversations with newsmakers, world leaders.
Good to be with you, Christiane.
Artists and